We are going to start now the next lecture, lecture 5 of chapter 1, class 11th, mathematics. In this lecture, we will talk about the Venn diagrams. So, we have seen in our previous lectures also this term Venn diagram we have used over there also. So, the definition we have is the pictorial representation of relationship among sets by means of diagram is called a Venn diagram. So, how these diagrams are being shown? We are saying the universal set, it is shown with the help of rectangles. The universal set we have, it is shown with the help of rectangles, and its subsets, they are shown as the circle inside these rectangles. So the first Venn diagram we are talking about, it is the diagram for A is a subset of B. So we are saying we are having this set A is there and this set B is there, and this diagram, it represents that A is a subset of B. Why? Because it is clear from this diagram that for each A element of A, for each x belongs to A, we have x belongs to B, and this is the definition for A is a subset of B. So we are saying this is the set A and this is the set B, and this shaded portion, this complete portion, this portion over here, this is the set B, and this is inside of it, it is set A. So this is the Venn diagram for A is a subset of B. Second we have is the Venn diagram for A union B, when neither A is a subset of B nor B is a subset of A. So again, how we draw the Venn diagram? We draw the universal set first. Then we are talking about two sets. One is this set A. This is the inside portion of A. And then we are talking about this is the set B. When we are saying union of these two sets, the shaded portion we are talking about, this complete portion, this A and B, this complete portion we are saying, this represents A union B. Third we have, this is the universal set. We are talking now about the Venn diagram corresponding to A intersection B, and neither A is a subset of B nor B is a subset of A. So again we have two sets over here. One is this set A and this is the set B. So what is intersection of these two sets? We are talking about this region over here. What this region represents? It means any point in this region. So this is the point X. Then what is the property of X? We are saying X belongs to A and X belongs to B. This is the shaded portion we have now. That in this region we are saying that X belongs to A and X belongs to B. Next we have this A union B, when A intersection B, that is equal to 5. So we are saying this is the universal set we are talking about, and these are the two sets we have. This is the set A we have and this is the set B that we have, and we are saying in this case, this is the case when A intersection B is equal to 5. A intersection B is equal to 5 means A and B are disjoint. Then A union B means this complete region A and this complete region B. So any point in these regions, the point X may be over here, the point X may be over here. So we are saying that X belongs to A union B means X belongs to A or X belongs to B. Next we have is we have the condition over here that neither A is a subset of B nor B is a subset of A, and we are talking about A minus B. We know the definition of A minus B. What is A minus B? It is all elements of A except B, that we are not considering the elements of B, or we are saying it is the set X such that X belongs to A and X does not belong to B. So this thing is shown over here. Universal set, again it is shown with this rectangle. This is the universal set. We are talking about, this is the set A we have. This is the set A we are talking about, and we have, this is the set B. So from the set A we have removed this portion of B, and we are left with this only this much portion of A, and this region it represents A minus B. That is from A, this is the complete set A. From A we have removed this portion that was common with B, and what we are left with is A minus B. Next we are talking about the symmetric difference. So again, universal set U is there, it is represented with a rectangle. We have two sets A and B. This region of A, this is the portion A minus B, this is the portion of B, this is the portion B minus A, and union of both these portions, this portion we are saying this is A minus B, this portion we are saying this is B minus A, and union of both these portions, that is the symmetric difference A delta B. So this is again, this is the case when we are saying neither A is a subset of B nor B is a subset of A, and A intersection B is not equal to 5. We are saying that these two sets, they are not disjoint. So this is the Venn diagram for the condition when we are talking about for the operation the symmetric difference. Next we are talking about the complement of A. So we are saying this is a universal set U. This is the set A we are talking about. This is the set A we are talking about. So the complement of A means those values of U which are outside this A. The values of U which are outside this A, that is the complement of this set A. So we are saying this is this portion, this green portion, it is representing complement of A. This blue portion, it is representing the set A. Next we are going to prove some identities or the laws that we have already studied using the Venn diagrams. So we have already proved this condition that A union B, this is the operation we have performed first, and then we take the union with C. Or if we are performing the operation B union C and then taking the union with A, both of these are equal to each other. So this thing we have shown with the help of Venn diagram. So we are saying first of all we have performed the operation B union C. These are the sets A, B and C. So when we are doing B union C, this is the region B we have. This portion we have, it is B. This portion we are saying it is C. So this shaded portion, blue and green and yellow portion we are talking about, this represents the region B union C. When we are taking the union with A, we are getting this region also now. This region is also included in it. So this complete region we have now, this complete region we are talking about, this is representing the region A union B union C. B union C we have already done, and then we have done the union with A, and this shaded region is represented over here. Now in this is the left right hand side of this equation. Now we are saying what we have done, this is A union B over here. We have calculated A union B first. So the region we obtain, this is the region, this is B. In this portion we are saying this is A. So this is the region we are saying this is A union B. Now if we take its union with the set C, this is the set C we have. This is the set C we are having. Now when we take the union with C, we obtain this complete region over here. We are obtaining this complete region over here, and this is representing the value A union B. This we have already seen. Then we have done the union with C, we have obtained this, and from these two figures we are talking, from these two figures we obtain that these two values, these are equal to each other, and this is what we have to prove. Next we have to prove the associative law for intersection. So first of all we are looking at this condition over here. So if we have to draw the Venn diagram for the right hand side, this portion we are talking about, so first thing we have to draw B intersection C. This is, we are saying this is B intersection C, and this is the region we have common between B and C. Now we have to take its intersection with this set A. This is the set A we are talking about. So in the next step we have taken the intersection with this set A, and the region common to all these three, we obtain this region. We are saying this is the value of A intersection B intersection C. Similarly, if we are considering the left hand side of this equation, this value we are talking about, first of all we have to calculate A intersection B. We are talking about A intersection B. So we are saying this region we have, this is A intersection B. Now we have to take its intersection with this set C. This is the set C we have. We are taking the intersection of these two regions, and the answer we obtain, it is this portion over here. This portion we are saying, after taking the intersection with this C, we are remaining with this portion. It is representing A intersection B intersection C, and clearly we can see both these regions, these are same. These regions, these are same, or we can say these are equal. So we are saying both these values, this thing proves that both these values, these are equal to each other. Next we are proving the distributive property. So we are proving the distributive property of union over intersection. So the result we are going to prove it is that A union B intersection C, this is equal to A union B intersection A union C. So when we are talking about the left hand side, first of all we have to draw the Venn diagram for B intersection C. So we have taken three sets A, B, C. This U, we are saying this is this rectangle, this is showing the universal set U. So when we are talking about these three sets, this region over here, this is representing the region B intersection C. Now when we are taking its union with A is this portion we have. Now what we have is, we have this region plus this portion. So the portion we obtain over here, it is this. The final answer, by taking the union of both these regions, we get that this is the portion we are talking about, and this is representing this A union B intersection C. So this is our left hand side. Next we are saying we have to draw A union B, and we have to draw A union C. So when we are drawing A union B, this portion we have shown over here, this is the portion, this shaded portion we are talking about, this is the portion A union B. Next we have to draw A union C. We are talking about this is A union C. So we have taken the union of A, this is the portion A, and this is the portion C. So this is A union C. This shaded portion, it represents A union C. And if we take the intersection of these two, so what we see is, look at this portion over here. We are saying when we take the intersection of these two, this portion, it is this portion over here, and then next we are saying this portion of B, this is common in both these, and this portion of A, this is common in both these regions. So when we take the intersection of both these regions, we obtain this region over here. When we take the intersection, we are talking about the common regions. So we are saying the common region we have, this portion of B and C is common. So we obtain that the final region we obtain, it is this region, and both these regions, they are equal to each other. So we are saying that both these values, these are equal to each other. So these results that we have already proved, these can also be proved using these Venn diagrams. And with Venn diagrams, it is quite easy to see the intersection, the region of intersection, the unions, and the results, they are quite visible from these Venn diagrams. But it is not always feasible to prove the results using the Venn diagrams when the things becomes very complex. Next we have is some diagrams for practical purpose. So we are saying, suppose we are given a universal set U. We are given this universal set U. We have two sets A and B. This is the set A we are talking about, and this is the set B we are talking about. So we have three portions over here. One portion we are talking about, it is this portion we are saying. This is the portion of A which is not in B. So we are saying this portion with green, that is representing A intersection B complement. Second, we are talking about this portion over here, that is common between A and B, and we are saying this is the value A intersection B. Third, we are talking about this outer portion over here. We are talking about this outer portion over here, and this outer portion we are saying this represents the value B intersection A bar. This portion is representing A intersection B, and this portion is representing A intersection B bar. So one thing that is clear to us from this is that all these three pairwise, this and this and this, and first and third, they are pairwise disjoint. It is clear that these are pairwise disjoint, means that this portion and this portion has nothing in common. This portion and this portion has nothing in common. This first and last has nothing in common. And second thing that we obtain is that if we take the union of all these portions, then that is equal to A union B. That if we take the union of all these three, then that is equal to A union B. This similar result can be extended for the three sets is shown in our next diagram. We are saying this is a universal set U, and we have three sets over here, A, B and C. This is the set A, this is set B, and this is the set C. These circles are there. Now we are saying what these portions are representing. This inner portion we have over here, this is representing the intersection of all these three regions. Now when we are talking about this portion over here, I am talking about this portion over here. So we are saying what we have done. This portion is the portion of A. It does not contain the element of B, and it does not contain the element of C. Does not contain the element of C means that it contains the element of C complement. It contains the element of B complement, and we are saying if I draw only this much portion, I am saying these are the three circles that we have. These are the three circles that we have. This is A, this is B, and this is C. So when I am talking about B complement, I am saying this is the region B complement. This yellow colored region, this is the region B complement outside B. When I am talking about C complement, so I am saying the region this outside C, this is the region C complement. And now we are taking its intersection with the region A. We are saying this is the portion, we are saying this is the portion A. So what is the common portion over here? It is this portion of A we are talking about. So this is represented over here as A intersection B complement intersection C complement. Now when we are talking about this region over here, we are saying what this region represents. This region has elements of A and elements of C and elements of B complement, because if we leave it up to this, that A intersection C, then it will include, I'm talking again, I'm drawing this figure over here. We are saying we have figure in this form, and this is the set A, this is the set B, and this is the set C. if I am talking about A intersection C, A intersection C means I am talking about this complete region over here. This is the region A intersection C. Now, if from this region we talk about, we want to remove this portion that is contained in B. We want to remove this portion that is the part of B. So, what we are going to do, this portion we are saying, this remaining portion we have, this portion we have, this is A intersection C intersection B complement. We are saying it contains the elements of A intersection C. This whole region is there, and then out of this we have removed these elements of B which are the part of B. So we have done it as A intersection C intersection B complement. This thing is more clear to us if we could relate it with this term, that when we are writing A intersection B or A intersection C intersection B complement, this thing means A intersection C minus B. It means from A intersection C we have removed the elements of which are common with B. We have removed the elements of B, so we are left with this portion. So we are saying we have A intersection C intersection B bar. So similarly we have these values, B intersection C bar or C complement intersection A complement. This is C intersection A complement intersection B complement. Then we have these values over here, A intersection B intersection C complement and B intersection C intersection A complement, and this inner value we are talking about, this is the intersection of all these three sets. Now next we have results from Venn diagrams. So suppose we have two non-intersecting subsets A and B of U. We are saying this is our universal set, and there are two subsets over here. This is A and this is the set B. This is the set A, this is the set B, this is the universal set U. We are saying there are elements in A over here, there are elements in B, and there are some elements which are common to both A and B. So number of elements in A, the set A we are talking about, the number of elements in A, that is equal to, when we are counting the number of elements in A, we are saying this whole set it is A, this whole set it is A. So the number of elements in A it is 1, 2, 3, 4, 5 and 6. When we are talking about the set B, this whole set, this whole region we are talking about, this is the set B we have. So the number of elements in B we have, that is equal to 1, 2, 3, 4, 5, 6, 7. Now when we are talking about this region over here, this is the region we are talking about, it is number of elements in A intersection B, and the number of elements we have it is 1 and 2. Now if we are counting the number of elements in A union B, A union B means we are talking about this complete region. So when we are counting the number of elements in A union B, so what we are talking about is, we are saying it is number of elements in A, all the elements in this region, plus number of elements in B. Now what is happening, if we add these two values, what is happening over here, that this portion we are saying, this intersection portion, this is counted twice. This is counted in A also, this is counted in B also. So we have to subtract the value n of A intersection B, or what basically we are saying, that when we are writing the value number of elements in A, it means we have counted all these values. Now what we have left with, we are left with the values in B which are not in A. So we are writing these values as number of values of B minus number of values of B which are common with A. So we obtain this formula over here, that n of A union B, that is equal to number of elements of A plus number of elements of B minus number of elements of A intersection B, and the answer in this case we will obtain, that is equal to 6 plus 7 minus 2, and that is equal to 11. So the total number of elements we have, it is 11. Now the next result we have is, if A intersection B is equal to 5. This is the value we are talking about. This is A intersection B, and this n of A intersection B, that will become equal to 0. Then the formula will become, it is number of elements of A union B, that is equal to number of elements of A plus number of elements of B, and this thing holds only when A intersection B is 5. It means A and B, they are disjoint. Next is, from the Venn diagram, this diagram we are talking about, we are considering over here that this is the universal set over here, and this diagram we are saying, what we are getting is, from the first diagram we have number of elements in A minus B plus number of elements in A intersection B. This gives us this region, and this is equal to the number of elements in A. Similarly, the sum of these two will give the number of elements in B, and the third result we have is that the union of all these three, because these three sets they are disjoint, so we are saying the number of elements in A minus B plus number of elements in A intersection B and number of elements in B intersection A, that is equal to the number of elements in, we are saying we have added this region to it, so that is equal to number of elements in A union B. The result that we have proved for two sets, it is number of elements of A union B, that is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. So this result can be extended for three sets in this form. We are saying, if we are talking about the number of elements in A union B union C, then that is equal to number of elements in A plus number of elements in B plus number of elements in C. Then we have to subtract the values of intersection of number of elements of intersection of A, B, then number of elements in intersection of B and C, and number of elements in intersection of A and C, and we have to add the value number of elements of A intersection B intersection C. The proof is given over here. We can also prove this result using the Venn diagram. We are saying this is the set A we are talking about, then we have, this is the set B we have, and this is the third set C we have. This is the set A, this is the set B, and this is the set C. So when we are saying number of elements in A, it means we have covered this whole region. We have covered this whole region. Number of elements in B, it means we have covered this whole region. So this portion we are talking about, now this is covered twice. Up to this point, this portion is covered twice. Now when we are saying union with C, so we get this kind of portion over here. So what we are saying, now this portion is covered twice. This inner portion we are talking about, this is covered thrice. Now what we are going to do is, we have subtracted we are talking about this inner portion over here. That is, we are saying this is A, this is B, and this is C. We are saying these portions, these are covered twice and thrice. So what we are going to do, we are going to subtract this portion, we are going to subtract this portion, and we are going to subtract this portion. Once when we will subtract all these three portions, so what we will be remaining, this portion over here, this portion I am talking about, this will be left only once, this portion will be left only once, and this portion over here, this will be left only once, because we have subtracted these three value once. Now look at this inner portion over here. We are talking about this inner portion over here. Now this inner portion is subtracted 3 times from this value, and it is being added 3 times. We are talking about this inner portion, it is being added 3 times, and it is being subtracted 3 times. So to finally, what we look at these two conditions over here. Earlier it was added 3 times, now it is subtracted 3 times. It means this portion is not being calculated. So to adjust this value, we have added this value over here, that it is number of elements of A intersection B intersection C. So this is the visualization that how this formula is being derived. And if you want to prove this formula, what we have done, we are saying that number of elements of A union B union C. So we have put the bracket on this A union B. It means we are considering this is a set, this is the second set. We have applied the formula. This formula we are talking about, that number of elements of A union B is equal to this. We have considered this complete value as A and this value as B. So what we get is, it is number of elements in A plus number of elements in B minus number of elements of A intersection B. Now to this term, we have again applied this formula, and we obtain the values in this form. This time we have applied this formula and we obtain the values in this form, and on adjusting all these values, we will obtain, this is n of A, n of B, and n of C. These three values are there. Then we have n of A intersection B, and over here we have n of A intersection C union B intersection C. On this term, we have again applied the formula and we obtain the answer in this form. And on solving this, you can check that you will obtain the final answer in this particular form. So you must remember this formula. This formula you have to remember, that when we are talking about the number of elements in A union B union C, then how we have generalized this formula, it is n of A plus n of B plus n of C minus, we have subtracted the terms by considering the intersection of two sets and added the term by considering the intersection of three sets. Now next we have problem based upon these formulas. So it is given that if A and B are two sets such that number of elements in A is 27, number of elements in B is 35, and number of elements in A union B is 50. We have to calculate the value of the number of elements in A intersection B. So we have just used this formula over here, that number of elements in A union B, that is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. This value we have to calculate, and these three values are given to us. This is A union B, number of elements of A and number of elements of B. So if we substitute these values in this formula, we will get the final answer. We are saying we have number of elements in A intersection B, that is equal to number of elements in A plus number of elements in B minus number of elements in A union B, and we obtain this answer for this question. Next is, if A and B are two sets containing 3 and 6 elements respectively, what can be the maximum number of elements in A union B? We are talking about maximum number of elements in A union B. So we are saying number of elements in A, it is 3. Number of elements in B, it is 6. Now, number of elements in A union B, the formula we have is number of elements in A plus number of elements in B minus number of elements in A intersection B. This value, number of elements in A union B, will have maximum value if this value is equal to 0, and the answer will be 3 plus 6 is equal to 9. So we are saying the maximum number of elements that it can have, it is 9, and this value will be there when A and B, they are disjoint, and the minimum value that A union B can have, it is when, what is the number of elements in A is 3 and number of elements in B is 6. So it means the maximum, when this value is maximum, we are saying this value will be minimum. So the maximum value of number of elements in A intersection B, it can be 3. Why? We are saying that A is a subset of B. The maximum elements will be there when we are saying all the elements of A are elements of B. Then A intersection B, the number of elements in A intersection B, that will be equal to 3. It cannot be more than 3 because maximum number of elements in A, it is 3. So the minimum value that we will have, it will be 3 plus 6 minus 3, that is equal to 6. So the final answer we obtain is that the maximum value of A union B is 9 and the minimum value of A union B, it is 6. Next question we have, a survey shows that 73% of Indians like apples, 65% like oranges. What percentage of Indians like both apple and oranges? So this thing is mentioned over here, that A is the set of Indians who like apples, B is the set of Indians who like oranges. So we are saying the number we are talking over here, suppose we are saying the total number of persons we have, it is 100. So we are saying the number of persons who like apple, that is equal to 73. Number of persons who like oranges, it is 65, and the total number of people we have, total number of people means A union B we have, that is equal to 100. This thing we have considered that out of 100, 73 like apple and 65 like oranges, because the values these are given in percentage over here. So we have to calculate those who like both apple and oranges. So the answer we will have, it is n of A plus number of elements in B minus number of elements in A union B. So that is equal to 73 plus 65 minus 100, and the answer we obtain, that is equal to 38. Next question we have is, in a survey 425 students in a school. So the total number of students we have, it is 425. So U is the universal set of students surveyed. So the number of elements in U, it is 425. It was found that 115 drink apple juice. So let A is the set of students who drink the apple juice. So number of elements in A, that is equal to 115. Next it is given that 160 drink the orange juice. So B is the set of students who drink the orange juice. So number of elements in B it is 160. And last it is given that 80 drink both apple as well as the orange juice. So this value 80, this is equal to the number of elements which drink both. Both means they drink apple and orange juice, and means it is intersection over here. We have to calculate how many drink neither apple juice nor the orange juice. So we are talking about the situation over here that this universal set, the number of elements in universal set, it is 425. The number of students who drink apple juice, we are talking about, suppose it is this portion, we are saying those who drink apple juice, this is the set A. So the number of elements in set A, that is 115. The number of elements in set B, that is equal to 160. We are saying these are the people who drink the orange juice, and this 80 is the number of people who drink both apple and orange juice, that is equal to 80. Now if we calculate the value of A union B, we will get the total value over here. The value of A union B we can calculate using this formula, that this is the value we are talking about. It is N of A union B, that is equal to 195. So this is the total value of this region. The total number of students we have, it is 425. The number of students A union B that we have, it is 195. So we are saying how many students are remaining. It means the students in this region, that will be 425 minus 195. These are the number of students in this region, and the answer we get, it is 230. So we are saying there are total 230 students who neither drink apple juice nor the orange juice. Next we have is, in a group of 850 persons, 600 can speak Hindi and 340 can speak Tamil. So the value of, suppose we are saying the Hindi speaking persons, the set of Hindi speaking person, it is represented with A, and the set of Tamil speaking persons, it is represented with B. So this is the number of elements of A, that is equal to 600. Number of elements speaking Tamil B, that is equal to 340, and 850, this is the value of A union B, that is equal to 850. These three things are given to us. We have to tell how many speak Tamil only. So we are saying this is the situation given to us. This is the set A, those who speak Hindi. This is the set B, those who speak Tamil. And in this value, A union B is given to us. So we want to calculate the value of A intersection B first. So the number of elements in A intersection B, that will be equal to number of elements of A plus number of elements of B minus number of elements of A union B. On substituting the value, we are getting it is 600 plus 340 minus 850, and the answer comes out to be 90. So we are saying the number of students or number of persons speaking both the language, that is 90. Now what value we are talking about? This value B, we are saying we have to calculate only Tamil. We are saying this B value we are having, the number of elements in B, that is equal to 340, out of which this region, the value of the number of persons in this region, it is 90. Now the person speaking only Tamil, it is represented in this portion, and the number of persons in this portion, that will be 340 minus 90, that is equal to 250. So we are saying there are total 250 persons who can speak only Tamil. Next we have is, out of 600 car owners investigated, so total number of owners it is 600. 500 owned car A and 200 owned car B and 50 owned both cars A and B. So we are saying if P is the set of people who owned car A, Q is the set of people who owned car B, should be number of elements of P, that is 500, number of elements of Q, that is equal to 200. Both A and B means this is the value of number of elements of P intersection Q is given, and there are total 600 owned cars. We have to verify whether the given data is correct or not. So this is the value of A union B. So we are saying if we put these values in this formula, that it is not A union B, it is P union Q. So if we put these values in this formula, that number of elements in P union Q, that is equal to this, then we can see that the values we obtain over here, this value it is 600, that should be equal to 500 plus 200 minus 50, and this value comes out to be 650, and this becomes a, this thing is, we are saying this is absurd. This thing cannot happen. So it means the data that is given to us, that is incorrect. This data is not correct. Now the next question we have is, in a group of 52 persons, 16 drink tea but not coffee. So suppose we are saying A is the set which represents the person who drink tea and B is the set of persons who drink coffee. So the total number of persons we have, it is 52. It means the number of elements of A union B, that is 52. Next, this 16 value is for the persons who drink tea but they do not drink coffee. It means it is number of elements of A which do not drink coffee, and 33 is those who drink tea. So number of elements of A, that is equal to 33. So we have to calculate the value, how many drink tea and coffee both. So when we are talking about both the tea and coffee, it means we are talking about, we have to calculate the value n of A intersection B. Next we have how many drink coffee but not tea. It means we are talking about the value B minus A. Those who drink coffee but they do not drink tea. We have subtracted out of these those who do not drink tea. So we have to calculate both these values. Now for the first part, we are saying the formula we have n of A intersection B, that is equal to number of elements in A minus number of elements in A minus B. Why we are saying so? We have seen this Venn diagram that when we are talking about A and B are two sets, this region over here, this portion over here, this is representing A minus B. This portion over here, this is representing B minus A, and this inner portion over here, this portion we have, this is A intersection B. So if we are talking about the value of this A, the number of elements of A, the formula we have, it is number of elements in A intersection B plus number of elements in A minus B. So by rearranging the terms, we will get that number of elements of A intersection B, that is equal to number of elements of A minus number of elements of A minus B, and this formula is used over here. So when we substitute the values in this formula, the answer we obtain for number of elements of A intersection B, it is 70. Now in the second part, we have to calculate the value of number of elements in B minus A. So we are talking about this portion over here. This is the number of elements in B minus A. So we know that the number of elements in A union B, that will be equal to number of elements in A minus B, this portion, plus number of elements in A intersection B, this second portion, plus number of elements in B minus A. This is the third portion we are talking about. Now out of these values, what we have to calculate is, we have to calculate the value of n of B minus A. We know that the value of n of A minus B, this value we know, this is equal to 16. The value of A union B, number of elements of A union B, no, this is equal to 52. Now we want to calculate the value of number of elements of A intersection B. Now to calculate this value, we have to use the formula that it is equal to number of elements of A plus number of elements of B minus number of elements of A intersection B. And this value we have, or this value we are saying, this value we have calculated over here. The value for this, it is 70. So the final answer that we will obtain, that will be using this formula, that number of elements of B minus A that we have, that will be equal to number of elements of B minus number of elements in A intersection B, and the answer we obtain, that is equal to 19. How we are getting this answer? This is 52 minus 16 minus 17, and the value we obtain, that is equal to 19, and this is the value of number of elements of B minus A. Now in this next question, it is given that in a survey it is found that 21 people like the product A, 26 people like the product B, 29 people like the product C. Next, 14 people like the product A and B, 15 people like the product B and C, and 12 people like the product C and A. And finally, it is given that 8 people like all the 3 products. So if we draw the Venn diagram over here, we are talking about, this is the set A, this is B, and this is C. We have marked the regions, the number of elements in the regions over here. We are saying in this region, we are talking about this region in A. We are saying, suppose the number of elements, it is A. Then this region we are talking about, the number of elements in this region, it is B. Then the number of elements in this region over here, it is D. The number of elements in this region F over here, this is the F. Then these are the elements in this region G and C. Now what is given to us is that the number of people who like product A, it is 21. So like the product A means, we are talking about, it is sum of all these 4 values. So what we get is that A plus B plus C plus D, that is equal to 21. Number of persons who like the product B, it means we are talking about the sum of these 4 values. So it is B plus C plus E plus F, that is equal to 26. Number of persons who like the product C, it is sum of all these values we are talking about. So sum of all these values, we are saying it is D plus C plus F plus G, that is equal to 29. Next, it is given that 14 people like product A and B. Now A and B means we are talking about this value. This is the common value between A and B. So it means the value of B plus C is given to be 14. Next, 15 people like the product B and C. B and C means the sum of C and F. It is given to be 15. And 12 people like the product C and A. C and A means we are talking about this region over here. So we are writing it is D plus C is equal to 12 people they like C and A, and last it is given that 8 people like all the 3 products. So for all the 3 products we are having this region C over here. We are saying the value of C that is given to us, that is equal to 8. Now we have to find how many people are surveyed in all and how many people like the product C only. So we have the value of C is equal to 8. If we put this value in this equation, we get the value of D is equal to 4. If we put the value in this equation, we will get the value of F is equal to 7. If we put the value of C in this equation, we will get the value of B is equal to 6. These are the 3 values that we have obtained. So these values, these are shown over here, that C is equal to 8, D is equal to 4, F is equal to 7 and B is equal to 6. Now if we substitute all these values, the value of C, then the value of D, the value of F in this equation, we will obtain the value of G as 10. Next, if we substitute the value of B, the value of B we have it is 6. We substitute the value of C, we substitute the value of F in this equation, we will obtain the value of E from here, and the value of E we will obtain that is equal to 5. And finally, when we substitute all these values in this first equation, we will get the answer for A from the first equation, and the value comes out to be 3. Now we have to calculate how many total people are being surveyed. So the total number of people being surveyed, it is sum of all these values, and the sum of all these values, it is 8 plus 4 12 plus 7 plus 6 plus 10 plus 5 plus 3, and answer comes out to be 43. So we are saying the total number of persons being surveyed, it is 43, and the number of persons who like the product C only. These are the number of persons who like the product C only. This region we are talking about, this portion we are talking about. The number of persons we have it is G, and the value of G that we have it is 10. This is the value of G we have. So we are saying the number of persons who like the product C only, it is G is equal to 10. So this is our answer for both these parts. Next we are given in a town of 10,000 families. So total number of families we have it is 10,000. It was found that 40% of the families buy newspaper A, 20% buy newspaper B, 10% buy newspaper C, 5% buy A and B, 3% buy B and C, 4% buy A and C, and 2% buy all the 3 newspapers. Find the number of families which buy A only, B only, none of A, B and C. So the numbers we can calculate from here. We are saying 40% of the families they buy the newspaper A. So the number of elements in A, that is equal to 4000, where A represents the set of the families, the sets of the families that read the newspaper or buy the newspaper A. Next, number of elements in B, it is 2000. Similarly, C, it is 1000, it is 10% of 10,000, that is equal to 1000. Similarly, we have calculated all the other values over here. Now we have to calculate the value of A only, B only, and none of A, B and C. So we move on to our next slide, and we are looking at this Venn diagram over here. We have a universal set over here. We are talking about this Venn diagram, and we have shown these values, that this is the value of A only, this B we are talking about. If we have to write what this value B represents, it represents A intersection B intersection C complement. It means it is the common value of A and B minus the values that are not in C. So these are the values we are talking about. These values, these are shown over here. Then we are talking about this is E, F, G, this is D, and this value it is C. Now The values that are given to us is number of elements in A, that is equal to 4000. So this thing means the value of this is given A plus B plus C plus D. This value is given to be equal to 4000. Next, number of elements in B. Number of elements in B means B plus C plus E plus F. This value is given to be 2000. Similarly, the sum of the values of this C, B plus C, this is C plus D plus F plus G, is given to be 1000. Then the next value we are talking about, it is A intersection B. A intersection B means we are talking about this portion B plus C. The value of B plus C is given to be 500. Next we are talking about B intersection C, that is given to be 300. So B intersection C means it is C plus F. And the next value we are saying it is A intersection C is given to be 400, and A intersection C means D plus C. Last it is given that the value of intersection of all these values, it is 200. So value of intersection of all these is 200, means this value of C is given to be 200. So by backward substitution, we are saying we substitute the value of C in this equation, we substitute the value of this C in this equation, we substitute the value of C in these three equations. From this last equation, we will obtain the value of D. From the next equation, we will obtain the value of F, and from the next equation, we will obtain the value of B. So we have calculated from these four equations, we have obtained these four values. Now when we substitute the value of this C, D, F and G, these values we are talking about, when we substitute these values in these equations over here, we will obtain the rest of the values, that is G, E and A. Now what we have to calculate is, the first thing that we have to calculate is, it is for A only, that is those who buy the newspaper A only. A only means we are talking about the value A. The value of A we have, it is 3300. So the answer for first part we obtain, it is 3300. Next is those who buy B only. So B only means we are talking about the value of E. The value of E we have, it is 1400. So we are saying the answer we are obtaining for the second part, it is 1400. Third is none of A, B and C. So none of A, B and C means we have to calculate the union of all these values, that is the sum of all these values. And when we calculate the sum of all these values, it comes out to be 6000. It means 6000 persons are there who buy the newspaper A or B or C. It means this value, it is the value of number of elements of A union B union C. Now we want to calculate the number of persons who do not buy any of these newspapers. It means we are interested in the complement of this union over here. So the complement value we will have, that is number of elements in A union B union C, that is equal to 6000. Number of elements in universal set, the total number of families surveyed, that is 10,000. So the number of elements outside this region, that will be the difference of these two values, and it comes out to be 4000. So we are saying there are 4000 families that they do not buy the newspaper A, B or C, or none of the newspaper A, B and C. So the number of families, they are 4000.